Hello everyone, welcome back to great program, Insight Fellowship program in Advanced Analytical Problem Solving Expertise. So where we stopped last time, we started with our operational liver diagnostics, and we decided to take a break and get to the next video after around 20-25 minutes. I'm sorry for that if you really found it breaking into your momentum, but that's really needed because that really freshen you up and so that you can understand these concepts well. I guess that's what the scientific rule as well. So on that particular note, let's move ahead and continue with where we left last time. So let's go to next slide. Right. So we started with operational liver diagnostics, and all we did was like you as a green belt are going to sit with operations team includes managers, supervisors for that matter, assistant managers, and instead of asking them the problem, all you're going to ask them are few simple questions. Question number one, well, what are different metrics are you maintaining? Then how frequently you are maintaining those metrics, shift wise, day wise, unit wise? What are the targets you set for those metrics? And post that, we try to find out what are the non-compliant performances. So how many number of shifts for that matter, or how many number of days for that matter, if you're maintaining daily metrics, right? So we try to find out how many number of those shifts or days are not meeting the target line. So that become a problem statement. So we stopped over here last time. Now let's continue on the very next slide with next few aspects of operational liver diagnostics. So let's go to next slide. Right, the next question number 5, which you're going to ask is, what are rough estimate of losses caused due to non-compliance of a given metric? Now we have seen in the previous few slides that we came up with a metric, how frequently we are maintaining that particular metric, shift-wise or daily basis. Then what is the target of that metric for last 3 months of time span? What is the non-compliance numbers we are getting, right? So we got to know about all these details. Now we need to check out. Okay, fine. I do have a non-compliance, but I need to convert that non-compliance in monetary losses, right? So non-compliance is bad if it is going to affect very badly to me, to my operations. And to find out whether it is affecting me badly or worstly, I need to check out, I need to convert that non-compliance into monetary losses. So very next thing, all we need to ask is question number 5. What a rough estimate of the losses when I'm having this much of non-compliance? Now, what is the rough estimate of monetary losses caused due to non-compliance? Mostly operational manager or operational head normally do possess this kind of information. By the end of the day, when you're doing business, you have to control your operational cost. And to control operational cost, you got to understand different areas where I could lose during my day-to-day operations. And that's why these companies do maintain, or many companies do maintain these details. So monetary losses. So you simply need to ask, okay, what are the non-compliance caused monetary losses? Will you just come up with this? So they will come up with a rough estimate, or maybe they'll take maybe half an hour's time, hour's time, a couple of hours time, and we'll come up with a rough estimation. So you got to give them that time. So here we get the answer to question number 5. Here you can see in a highlighted column that for a given company, this is in this hypothetical case. Actually, when I'm saying hypothetical, this is actually the case which we implemented. But since this is a classified information, we cannot give the name of the company, right? But these are the actual numbers. Imagine, let's take in first row or first metric, percentage defective, which we maintain it shift-wise basis. Target is 3%, or target was 3%. Total number of shifts given company work in last 3 months is 234. Why last 3 months data? Why not last 1 month or 2 months or 6 months or 8 months or years data? 3 months is like a typical, average out number. 1 month is relatively lesser. 6 months perhaps is a better number, but maybe company is not maintaining the details that long. So we are seeing last 3 months data companies do maintain. Last 3 months means 1 quarter. So 1 quarter's data company do maintain and can find it easily, to be very honest, because that is also another challenge, finding these details that easily during the session, right? So 3 months is sufficient, to be very honest. So 234 weeks, and out of which 48 weeks were non-compliant, and that lead to $100,000 worth losses for the company. And likewise, we did it for other metrics as well, other levers as well. So percentage scraps cost around $20,000, and then percentage rework cost around $30,000. And that's how it kept on going. And total losses at the bottom, you could see in a red highlighted sales. It's a accumulation of the total losses. Again, this is the estimated, rough estimated numbers. There might be a few chances that number will differ here and there, but these are the rough estimation that company do face or do get losses of around mm, uh, 3.46 lakhs or $346,000 is what they are losing. Roughly in Indian currency, since it was an Indian company, in Indian currency it was close to 2.42 crore rupees. So Indian rupees around 2.42 crores. So 242 lakhs, or in the terms of millions, it would be 24.2 million rupees. That's what the losses they had. So that's about the question number 5. By the way, when I'm talking about these losses, please do remember these are not the daily losses or weekly or monthly losses. These are the annual losses. So I'm sorry, I need to mention rough estimate of annual losses. Please read it as a rough estimate of the annual losses. So annually, this given company is losing on these metrics and the non-compliances of these metrics. They're losing close to 2.4 crore rupees or 24.2 million rupees. That's what the estimated annual losses they had. So let's go to the next slide. Right. So here, once we got that total losses, estimation of the total losses, we got to reduce those losses, and that's why basically, in the first place, we are coming up with this diagnosis, right? So we have to establish goals for each metric. So we'll come up with the goal, like establishing the goal of reducing non-compliance by roughly 15 to 20% for improvement projects. So we have 9 different metrics, and out of these 9 different metrics, we have to come up with a goal for each metrics improvements, right? And then we'll come up with the 15 to 20% of improvement, a goal, right? So when 48 was your non-compliance weeks, for last 3 months data for percentage defective, here you can see, I'm just highlighting it over here, 48. The goal would be 48 to 39. So reduce the number of non-compliant weeks from 48 to 39. For sake of percentage scrap, reduce the number of non-complying week. Again, let me repeat. We are talking about number of non-complying weeks, right? So reduce it from 42 to 34. And likewise, we'll set the goal for each and every metric. That is the next thing we did. So we started with understanding number of metrics they are maintaining, how frequently they are maintaining or collecting the data for the metric, shift-wise, day-wise, or unit-wise. Then what was the target, or what is the target they do have for a given metric? Then how many number of shifts, or for that matter, how many number of days they are not meeting that given target. We try to find it out, right? Once we achieve that, we try to find out the estimated annual losses out of that non-compliance. Once we achieved it, we cumulated the total losses. Then we set the goal. The goal would be reduce number of non-compliant weeks from number of non-compliant shifts from by 15 to 20%. That's what a goal we set. Let's go to the next slide. So next slide will talk about estimated improved state. So estimated improved state would be you were standing at 48 non-compliant weeks with the goal of 20% improvement now, or your expected improved level would be 39 weeks, 39 non-compliant weeks. It is not possible that from 48 non-compliant weeks you'll reduce it dramatically to 0 weeks. Slowly and continually keep on reducing it, right? So maybe in a first phase of improvement project, we reduce it from 48 to 39. 39 is also a huge number, but that is achievable. Always remember, every single goal which we set should be attainable, right? So we might set the goal of 48 to 0, but that is not possible. That is not feasible to achieve. That's why we set the first goal of 39, reach to the 39 weeks, non-compliant weeks of 39 now. 39 non-compliant weeks. That is also huge. Maybe the next phase, which we call a rebaselining, we reduce it from 39 to 30, right? From 30 to maybe 25, or for that matter, 20. And likewise, you keep on doing 2 or 3 iterations or cycles under which you can reduce total number of non-compliant weeks for a given metric of percentage defective from 48 to maybe 15 or 20 or maybe 10, but that will need a few cycles. But for time being, we'll focus on reducing it from 48 to 39 weeks. So that's what our goal is. Our goal is to reduce non-compliant total number of non-compliant weeks from 48 to 39. So a non-compliant shift. Please do here shift and not weeks. A bit confusion. So total number of non-compliant shifts were 48, reduced it to 39, right? So that's what the estimated improved state of 39 shifts. Let's go to the next slide. Now here, write down what would be an estimated loss status after completing improvement project successfully. Now we got a goal, and what if we achieve that goal? How much would be my losses by then? If my losses were standing at $100,000 right now, when I have 48 non-compliant shifts, when I reduce it to 39, what would be my estimated losses by that time? So we'll just jot it down over there. So here, if we reduce it from 48 to 39, total losses of $100,000 will get reduced to $81,250. It's a typical mathematical calculation. Again, this is rough estimation. Before we start implementing the project, this is the estimation, rough estimation. So probable losses after improvement project would be 81,250 for percentage defective. Percentage scrap, it would be $16,190. For number of complaints, it would be $15,000. For number of accidental incidences, it would be 7,333, roughly 7,000 and $340. So this is rough estimation of future state losses. So let me read out that point. Write down what would be an estimated loss status after completing improvement project. And I give an example as well. Before improvement project, if your losses are around USD 100, this is just an example. And after project, losses status for a given metric will roughly reduce to say USD 70. So in case of percentage defective, we are standing right now at $100,000. Once we improve our, once we deploy the improvement project, we will reach to $81,250. The losses of $81,250, which is also high. And as I already told you, you have to again re-baseline the project in the next cycle and reduce it from 81,250 to maybe $60,000. So likewise, slowly and continuously, we keep on improving, right? So at this current junction, we are talking about probable losses after first improvement project in the metric of percentage defective. It would be 81 to 50, right? So let's go to next slide. Next slide on next column talks about, so how much would be estimated saving? So from $100,000 to $81,250, how much is the saving? Roughly $18,750. It's a mathematical calculation, A minus B. That's it. So calculate estimated savings of a given improvement project by deducting losses after from losses before. So losses before minus losses after. Before means before improvement project, and after means after improvement project. So if you continue the previous example, in previous example, losses before improvement project were USD 100, losses after improvement project was standing at USD 70. So savings are around USD 30. So in case of defective, we said the savings are around 18,750 rupees. Again, this is the estimated saving. In case of percentage rework, it would be USD $5,610. In case of percentage yield, it would be $9,090 roughly. So that is how we came up with the total savings. At the bottom, we have a accumulation of total estimated savings after deploying these projects. So it would be $80,467.09, roughly 80,500. If you could just make it roughly, it would be 80,500 USD is what estimated savings we are talking about after deploying these projects. In Indian currency, it would be 56.33 lakh rupees. That is roughly 5.6 million Indian rupees. That's what it would be. Right. So this is how we did all these diagnosis. And now we'll go to the next slide of project priority. Now let's understand what is project priority. We cannot work on all the projects. These are just an example of 9 areas. There might be, say, 10 or 15 different metrics. Every single department might be maintaining it. So you can imagine they are close to 50, 60 different metrics maintained by a given company across every department. And in every single metric of every single department, we have to work and bring that improvement by deploying Six Sigma, Lean, and process optimization based problem solving methodologies, right? Can we work on 50 different areas in one go? We cannot work. So we got to prioritize. How are we going to prioritize number of projects? Based on the dollar savings. Higher the dollar savings, higher would be the priority. Lower the dollar savings, lower will be the priority. That's a simple equation. So let me read it out. Finally, based on estimated savings of a given metric, we can prioritize and plan the timeline to execute an improvement project. Of course, metrics with a higher estimated savings will be prioritized for immediate implementation. So out of these 9 so-called cases, we can see that percentage defective, total processing time per unit, and percentage warranty cost per monthly operational cost had or will have relatively higher saving amounts, right? And that is why for a given quarter, we will take these 3 projects, we'll work on these 3 projects, Next quarter, we'll work on some other metrics which do have relatively lesser savings. And then for the next to next quarter, we'll work on those metrics which will have lowest possible savings. And likewise, we'll keep on deploying. So this is a business excellence based program. So when you're talking about multiple projects, it's become a program. We call it business excellence optimization. So this is the business excellence based optimization program. Every single company should go ahead and deploy. So when you deploy the whole program for the whole year, you can imagine the savings will be in a multiple $1 million. This is what we normally do, and that is why I'm just sharing it with you. And this is supposed to be done. This is how we'll just go ahead. So let's move to the next slide. So here we are almost done with the first tool of diagnosis, right? So we are done with the first tool of diagnosis, operational liver diagnosis. Now let's go through one example, Lean Six Sigma success stories in the medical industry. We talked about biotechnology industry, we talked about automobile industry, with a couple of examples of agile and technology and that of Mazda and Ford. Now we're talking about medical industry. Quest Diagnostics is a company. They use the power of Six Sigma quality, and by using it, they achieved more than 85% defect reduction in wait time with no additional staffing, achieved 60% reduction in specimen processing accuracy, achieved more than 80% defect reduction in missing or lost specimens. These are the metrics they do have, by the way. Achieved more than 75% reduction in instrument measurement variability. Achieved more than 50% reduction in outbound P&P calls. They have achieved more than 60% defect reduction in hospital neonatal intensive care specimen collection errors. And that is how they brought the improvement. And that is how they saved dollars for them. On this note, let's move to the next slide, please. Right. So let's go to questions in this particular session. Whatever we have studied, we'll just go through those questions. MCQ questions. So operational levers diagnostics is a tool of finding and prioritizing problems or causes. And the answer is problems. Operational levers diagnostics is a tool of finding and prioritizing problems. It's not a tool of finding and prioritizing causes. It's a tool to find to find out problems and of course prioritize them so that based on the priority we can deploy those projects immediately or maybe in a coming future. So that's about operational levers diagnostics. Next question. Operational levers diagnostics focuses on finding number of non-compliance incidences against target and set improvement goals. True or false? And the answer is true. So operational levers diagnostic, what it does, it asks you what are different metrics you are maintaining, then how frequently you are maintaining it, shift wise or day wise or unit wise, and then what's the target for the given metric, and over the last 3 months, how much is a non-compliance. So trying to find it out, and based on that, it go ahead and set the improvement goal. So if you could remember, in our operational level diagnostics template, we talked about the percentage defective as one of the metric, and out of 234 weeks, 48 weeks were non-compliant. Sorry. Out of 234 shifts, 48 shifts were non-compliant. So we kept the goal of reducing it by almost 20%. So from 48 non-compliant NC ships to 39 NC ships. That's what the improvement goal we set, right? And that is why operational levers diagnostics focuses on finding number of non-compliance incidences against target and set improvement goals. So I guess on that note, we are done with a very first step, or for that matter, very first tool of define phase to diagnose problem. In the next video, we'll just go and see another tool, another very valuable and powerful tool called FMEA, failure mode effect analysis. And based on that, also we can find out and prioritize the problems. So I guess on that note, we are done with today's video. So I wish you a wonderful day ahead, a wonderful time ahead. Tishta Bharata, Ma Bharati shall rise again in her full glory. Before we end, let's thank few of companies who supports are very important for us. We deeply appreciate following technology companies for their technological support. Well, by the way, these companies are not our sponsors, but we have to say thanks to them. Without their support, we wouldn't be reaching out to you. So thanks, very big thanks to all these companies.